Hi. In this video and also the next video, I will show you in a bit more detail how a C program actually gets translated into an executable. Because there is more than just one tool involved. It's a complete tool chain. That means several tools that work together with each other. And first of all, I will give you an overview of this tool chain, what tools are involved and how are they connected with each other. And then in particular show you more about this first tool in the chain, the so-called preprocessor. And I will show you how you can actually work on the command line with this tool so that you can see by yourself what this tool can do and how to use it so that you get a pretty good understanding. You already know how to write this Hello World program into a file, compile it with GCC into an executable, which is by default called a.out, and what actually happens when you run this a.out, when you type in a.out on the Unix shell and hit return. That this program first gets loaded into the memory. The executable contains these descriptions of the text segment, data segment, and PSS segment, and then this sequential execution of these instructions of the text segment begins at some entry point. But this executable is not generated by one single tool. Actually, this GCC is just a wrapper for a bunch of tools, and I will show you how this C source file gets first processed by the so-called C preprocessor, and the result of this preprocessor then goes through the actual C compiler, and the result of the C compiler will be some assembly code which then runs through the assembler. And this assembler will not generate the executable, it generates an object file which already has machine instructions, but it's not executable because there is still in general something missing, which then be added, or the right term would be linked by the linker. And what gets linked are certain libraries. And the result of the linker then gives you this a.out. In order to see what the C compiler actually gets as input, we can stop this translation process after the preprocessor is done with the option -uppercase E. And in the demo I will first show you that in the simplest cases the preprocessor basically passes a copy of the source file to the C compiler with some additional information, like for example the file name of the source file, so that the C compiler can generate meaningful error messages, which certainly should contain the name of the source file. You will also see that the preprocessor removes all the comments from your source file. And of course I also show you how to change this default behavior of the preprocessor of just making basically a copy of the source file with so-called directives. Of course, I will show you the effect and the meaning of this include directive, which basically just includes a certain file, but also other directives, and they will actually be needed if we really look into the details of this include directives in the Hello World program. These are, for example, so-called define directives for defining macros, and you will also see how macros will be expanded by the preprocessor, and so-called conditional directives. So here on the left you see some source file foo.c, which certainly cannot be translated into an executable. But it's about what is the preprocessor doing with this input and what would the compiler actually see. And the compiler would see this here. And you see, most of it is actually just what you see from the source file on the left, but you have these additional lines, or these lines that begin with a hashtag followed by a space. And that means the compiler can distinguish what is supposed to be C code, which then somehow should be translated into some assembly code. That's everything that doesn't begin with a hashtag followed by a space, and what is additional information provided by the preprocessor. Everything up here. And this includes the information about, for example, the name of the source file, for generating, like in this case, some error message. So the compiler knows about this file name of the source file because it got this information from the preprocessor. Next, I want to show you how to use comments in your C code. There are actually two kinds of comments. This here with 2 slashes is a so-called single line comment. That means you can type after this 2 slashes whatever you want, and the rest of the line is considered to be a comment, which is for you and not for the compiler. So the preprocessor will remove it. And this means if I would insert a comment here, the rest of the line would be part of this comment. If I want that the rest of the line is actually something the compiler should see, then I have to use a line break here. If for some reason I want to have a comment in the middle of some code, I would have to use this other kind of comment, which is beginning with this slash followed by an asterisk. Then I can type in my comment, and I can end this comment like that with an asterisk followed by a slash. And you also can use this second kind of comment for multi-line comments, for example like that. And now you will see that this gets removed by the preprocessor. Not nicely, because you get this additional new line here, also here a few new lines, but it's gone. Now the next thing I want to show you is how you can do this macro expansions. For that I will use here a new file. And I will begin with a simple hello world. Above that I will now use this define directive to tell the preprocessor that hello should be replaced with hello. Make it a bit more German. Now let's see if this is actually done by the preprocessor. Yeah, we have hello world. Now next, let's see if this is simply a search and replace, as we know it from text editors. So for example here I remove this H, and a simple search and replace would mean that this hello would be replaced with hello. But you see, nothing was done by the preprocessor. We still have hello world. Like the Unix shell, this input processed by the preprocessor first gets grouped into tokens. And the rules how this grouping is actually done and what kind of tokens are recognized by the preprocessor are basically the same as for the C compiler, so we can talk about that later. For now it's sufficient to see that this hello world is separated with this white space, so we have here 2 tokens, hello followed by world. So now let me change this back so that hello again gets replaced with hello. Let's also see that this is the case. And now I will put this directive into the last line. Let's see what now happens. And then you see again there is no replacement. And from this observation I can give you some idea how the preprocessor is working. The preprocessor reads the file line by line, and if a line begins with a hashtag, it's containing some command to the preprocessor. In this case it's a command telling the preprocessor that from now on hello should be replaced with hello. And because this comes after hello world, it has no effect. Let's change this back. We now also could play around a bit. We could use here a second define directive stating that hello should be replaced with who with 2 tokens. That's also possible. And let's see. Yeah. So you see if such a token or macro gets expanded with something which can be expanded further, this is done by the preprocessor until no further rule applies. Now let's also change here the order like that. Then you will see this is okay, because now the idea would be I am telling the preprocessor hello should be replaced with these 2 tokens. And hello should be replaced with this hello. And now all these rules are known before this text is seen, so should have the same effect. And that's actually the case. You also can define macros that take one or more parameters. Let me show you an example where I'm defining first the macro foo with one parameter x, and this should be expanded to int main puts x. So I'm here using this argument, and that's it. Now I can use this macro, for example, with this string literal hello world like that, and then let's see what the preprocessor is doing. So it will pass this to the C compiler. Now recall that I'm using actually Clang here because I'm a Mac user, and Clang will, by the way, not accept this code for translating it into an executable. But if you use GCC, at least in this version, this should actually compile into an executable after some warnings. And actually working. Now, let's continue with this so-called conditional compilation. I will first put this foo inside of an ifdef directive. After this ifdef, short for if defined, I have to write some macro name, which either is defined or not. In this case, it's not defined. Then comes this foo, and then I will end this with endif. And after that, I will just type in something like x, y, z, something like that. Now, the preprocessor will process this file as follows from the first line to the last line, and when it hits this ifdef, it checks whether bar is defined or not. And if it's defined, then it will consider the following lines until the corresponding endif is found, and otherwise this here will be ignored. And this should be the case now, because we don't have any definition for this bar. And that's what you actually also see. Now we can define it. Just use an empty expansion, but it's defined, and then it is not ignored. You have it. Okay. You also can invert this with if not defined, short if ndef, and now things are just the way around. And you also can have an else branch, by the way. Let's say I either want to have a German or English version of this output. So then I can, in between these two, put this else directive. And because bar is not defined and we have this if not defined, we should get the English version. And if we would define now bar, we would get the German version. Like that. Now, finally, I also want to show you this include directive. And for that, I clean here this up. I will just use the following include bar.c. So I'm including myself. This will cause some problems to the preprocessor because it recursively includes itself. Now I will do the following trick. I will define here bar, and before that and I want to include a file called bar.h. Recall this source file here is bar.c, the typical file extension for C files, and .h is the typical file extension for so-called header files. Now, at the moment I do not have such a file in my home directory, so I expect some error message. Here we go, file not found. Yeah, it's kind of clear. So let's create it. This is just an example. Try again. And here we go. Now you see the C compiler will know that this line here, for example, comes from bar.h. And lines coming after that would be from bar.c. So maybe we should change this example. This is it. That's part of bar.c. And now you see we have this line from bar.h, and the C compiler would know the origin, and this is from bar.c. Now let's go back and include this twice. Then of course what we expect is that we now have this line twice. In both times the compiler will see that it's from bar.h. And this will be a problem in the future, that this header file should be only included once. And it will be not so simple to avoid it, like here, where I just see, oh, of course, I included it twice. Now the right way to do that will not be to remove here this includes, because you cannot avoid that you have more than one include for the same header file for some reason. You have to use here these conditionals. So I have to make actually changes to this header file. And I will do this like that with a so-called include guard. This is a certain pattern. It always begins with an if not defined, and then usually the name of the header file in uppercase, and the dot becomes an underscore. And after that, I'm defining this bar h. And the last line will be an end if, maybe with some comment stating to what this is actually corresponding. Now, the idea is, if for some reason somebody includes this twice from the same source file, the first time this if not def will always be true. The macro is hopefully nowhere else defined. So the preprocessor will read the following line, the define directive. So from now on it is defined. Then it also will process all the lines here, and then of course we have this end if in the end. Now if we include it a second time, then this whole thing gets ignored. And that's why it's called an include guard. It's guarding the content so that it only can be included once. And here we can convince ourselves that it's actually working. We only have this once. This include guard pattern you will also see in the header files of the standard library, for example in standard io.h. And of course, as I said before, we will also use this very often. As soon as we have more than one C file in a larger project, we will need this header files and this include guards. Before I show you the standard IO header file, let me first show you the difference between using quotes here and these angles. If you're using quotes, it means the preprocessor will search for a file in the current directory. And if you use these angles, the preprocessor will search for the file in the so-called include path. That's actually a list of directories, and it will begin with the first directory in this list, searches it there. If it's not found, goes on with the next, and so on, like the path on the Unix shell. And in my installation, the current directory is not part of that, and I'm pretty sure that's also the case in your installation. And that's why I get this error message, where I see here in line 2, this include fails because this file is not found. Now, if I want to add the current directory to the search path, I can do this with this option -I. After that, I just specify the path, dot without a space, and now I'm rid of this problem. Now let me show you the standard header for I/O on my machine. And libraries, developers, command line tools, SDKs, and here I have different versions, and that's what's used by GCC on my default configuration. Then in users include, and then I should actually have this standard io.h. Yeah, so this is the header file that I include in my Hello World programs. Now let's see where the include guard starts. Here, let's mark that and go to the end. Then you see this is the end of the include guard, like you saw before. And then you see right after the include guard, the next include comes. And you could go in there, in the same directory. Then comes the next include guard, and after that the next includes. And if you would look into this header files, you also would see include guards, and you also get an idea why you need this include guards, because quite impossible to make sure that otherwise you don't include something twice, which would cause problems. Now, what is it what finally the compiler sees? I mean, it's hard for us now to go through all these files and to get a idea what actually gets included. But of course, we don't have to go all through this by ourselves, because the preprocessor is already doing that for us. So here I just changed it to the Hello World program. So we just use the option -E to see what the C compiler actually gets after the preprocessor is done. So that's it. Also quite a lot. So of course we also know how to use pipe and less to page through this. Also kind of lot of things to read, but then we also can search just for printf, because hopefully this printf which we are using here in some mysterious way is somehow declared up here. And then you see there are quite a few printfs, but only this one here has not something like an S or something in front. We also could have searched with space printf. And now for the next step to understand what the C compiler actually is doing, I will replace for the next video just this include with this line. Because from all these things that were included, you will see that this is the only line that is actually needed for this Hello World program. So lots of stuff was included just for the sake of it. Not exactly, but kind of. Now you see, if you just have this line, you don't have an error anymore. And actually also this stuff here is not needed. And also this I wanna not explain in the next video. So long story short, what we use the preprocessor for the Hello World program for is to get essentially this line. And with that line, you can compile it even if you turn on all warnings without getting any problems. I just covered a few features of the preprocessor so that we later can use this include guard pattern, and that we now understand that this first harmless looking line in the Hello World program actually causes quite some action within the preprocessor. But then in the end we saw essentially it was just including this declaration of the printf function, which now shows us this would be the input of the C compiler, which is in the toolchain the next tool, which I explain in the next video. Bye.